Okay, so today we are going to work on solving applications of matrices. Remember, applications is a euphemism for word problems. So we're going to be solving word problems using matrices. First, you want to read the problem and identify or write down what you are being asked to find. Because whatever you're asked to find, those quantities are going to become your variables. Once you identify your variables, you can go back, reread the word problem, and write the equations that are being discussed. Since we're doing this with matrices, we're going to write the problems in our matrix equation, so the form AX equal to B. We're going to solve those matrix equations. And then we are going to write our answer with units or explanation. Which means without the matrix. Yeah. It's not enough to be able to solve these. I know that's a feat in themselves, but you also have to be able to explain what you found. Because if you can't explain what you found, how are you going to explain it to somebody else? All right, so example number 1. Mr. Jimenez is selling produce at a local farmer's market. His first customer bought 6 pounds of pears, 5 pounds of jackfruit for $52. The next customer bought 5 pounds of pear and 2 pounds of jackfruit for $27.95. They want to know how much per pound did Mr. Jimenez charge for each type of produce, which means we have our variables. Okay? Our first variable I'm going to call X. That is going to be price, because how much is price per pound. It says of each type of produce. First one they listed was pears. So price per pound of pears. That'll be X, which means Y is going to be my price per pound of jackfruit. So we just did our first step. Second step says read back through the word problem to write your equations. All right, so my equations. Mr. Jimenez selling produce. Yeah, I don't really care about that. That gives us background, but no numbers involved, not telling us anything. Says his first customer bought 6 pounds of pears and 5 pounds of jackfruit for $52. Now, if I was at the store and bananas were on sale for $1 a pound, I know that's expensive for bananas, but just go with it. And let's say I bought 3 pounds of bananas. 3 times 1 gets me 3, which means I would spend $3 for those bananas. Let's say I was buying blackberries for $3 a pound, and I decide to buy 4 pounds. 3 times 4 gets me 12. So to find how much I'm spending on any type of produce, I need to multiply the number of pounds and the price per pound. So my first equation, I have 6 pounds of pears, so that's going to be 6x. And so I'm going to put that together, add it up, 5 pounds of jackfruit, so 5y, and I paid $52. I'm customer 1. The next customer, new line, bought 5 pounds of pears, so 5x, and 2 pounds of jackfruit, so 2y, for $27.95. So our equation is equal to 2795. Step 2 of our process says we need to write our equation in AX equal to B form. Okay. So remember, A is our coefficient matrix. I'm going to have 6, 5, 5, 2. Because the coefficients from the first matrix are 6 and 5. X and Y get their own columns in A. And each equation gets its own row. X is going to be XY. So I have a 2 by 2 for A, a 2 by 1 for X, and B is what we're equal to. Remember, each equation gets its own row. So we are going to have another 2 by 1. Because we are solving this by hand, and we know that X is equal to A inverse times B, we need to find A inverse. Remember that A inverse is equal to 1 all over AD minus BC times our crazy matrix where D and A flip-flop and we negate on the backswing. Remember, little a, little b, little c, little d. So plugging into the fraction, which is with our determinant, we're going to have 1 all over 6 times 2, that was a times d, minus b times c, 5 times 5. And then our crazy matrix where 2 and 6 flip-flop, and we negate on the back diagonal, on the back swing. 6 times 2 is 12 minus 25 means that we have negative 1 all over 13 times our crazy matrix. And now we have multiplication by a scalar, which means that we need to distribute that negative 1 over 13 through our entire matrix. And we find out that A inverse is equal to, when you get decimals, convert back to a fraction. Should have negative 2 over 13, positive 5 over 13, positive 5 over 13, and negative 6 over 13. Nobody reduces. Now that we have found A inverse, we can now do X equal to A inverse times B. So we're going to take our A inverse, which was the negative 2, 13, 5, 13, 5, 13, negative 6, 13, times our B matrix, which was our equal to matrix, how much we bought total, 52 and 27.95. Remember, you need to check to make sure that you can multiply these. And I know you're thinking, well, you're giving us this word problem. Isn't that enough? Isn't that enough struggle? Well, yeah, but you still should double check to at least figure out what your result is going to be. Since the middle numbers line up, they're good. And our result is going to be a 2 by 1, which makes sense because we were looking for 2 variables. And remember, we're going to take rows times columns. Okay, since I need a 2 by 1, that means I need 2 rows, 1 column. We're going to show all of our work. We're going to have row 1 up top, row 2 down below, and column 1. They're both in the first column. And we are going to do RC COLA, rows by columns. We're going to have negative 2 over 13 times our column, so times 52, plus, because it's always plus, 5 over 13 times our 27.95. Remember, it's the first two multiplied together, second two multiplied together. Since we have taken row 1 and multiplied it by column 1, we're done with row 1. Let's go ahead and go to row 2. We're going to have 5 over 13 times 52 plus, because it's always plus, negative 6 over 13 times 27.95. Yes, you have to show all this work. When we solve this, we get 2.75 and 7.10. This is in a matrix. And remember, this is matrix X, which was equal to little x, little y. You can't stop here. We need to explain what we found. X is going to be $2.75 per pound. And that was, again, for pears. And Y is $7.10. You need to have the 0 because money goes to 2 decimal places and we don't write 7.1 if we mean $7.10. And that was per pound for our jackfruit. Okay. So as a recap, go through, write out what they're asking you to find, write the equation, write it in AX equal to B form, find A inverse, and then multiply that guy by your B matrix, and then finally explain your answer.